Hello students, this is lesson U2A01a. Hopefully by the end of the period you should be able to say I can perform reflections over a line on a coordinate grid. Let's take a look. Okay, so reflections are actually a part of a family of different types of transformations in geometry. And when I say transformations, we are taking an object and we are manipulating it. Okay, so what are the different ways in which we can manipulate this object or said object, right? Well, we can take the object and perform a reflection. We can reflect it over a line. Okay, so if I have a triangle over here and it's to be reflected over that line, it would land on the other side having its mirror image, right? So that's a reflection. A translation in geometry is simply taking said object and we are moving it around. So a synonym to the word translation is moving, okay? We're moving it in the horizontal direction as well as moving it in the vertical direction. So it doesn't have to be both. It could be just one or both of them together, okay? So let's say if I move this in this direction here, then I'll end up with a triangle that's located there, okay? So that's a translation. A rotation is exactly what it sounds like, okay? We're taking the object and we are rotating it. And usually the point of rotation needs to be specified, okay? On a coordinate grid, most of the time, 99.99% of the time, it will be rotated over the origin. And then a dilation is taking said object and how we're manipulating it is we are either blowing it up or shrinking it down. So a dilation is either blowing something up or shrinking something down. These four transformations are all part, or actually not all four of them, but three of the four of them, okay, are a part of a family of transformations known as rigid motions. So what exactly is a rigid motion? A rigid motion is a transformation that preserves length and angle relationships. So let's just think about this, okay? If you have a triangle and we reflect it over to the other side, right? We reflect it over to the other side. Have all the lengths changed? Right? Have all the lengths in this triangle changed? If you're thinking, nope, it hasn't changed, you're absolutely right, okay? So that is something that we consider to be a rigid motion. Okay, if we were to take triangle ABC and perform a translation where we're moving it around like so, okay, has the length changed? Absolutely not. The length of this has not changed. If we take this triangle and perform a rotation, okay, let's say a 90-degree counterclockwise rotation, a 90-degree counterclockwise rotation here, actually, it would not look like this. It would look like this. Okay, if I take that triangle and rotate it 90 degrees, okay, in this direction here, 90 degrees, okay, has all the lengths on that triangle changed at all? Absolutely not. That triangle has not changed. The orientation of it has changed. However, the lengths, okay, and the angle measures, okay, within that triangle has not changed. So the only one that would change that is not considered a rigid motion is a dilation. So if I have a triangle like so and I blow it up, none of the lengths are going to be the same anymore. So a dilation is not something, it's not considered to be a rigid motion. And a way to remember this, a rigid motion, when you hear the word rigid, okay, it means non-changing, right? So the size and shape of the original object does not change. That's a rigid motion. Okay. All right, so the next, what we're going to try and do is we're going to try and reflect triangle ABC, which has these coordinates 2, 1, 6, 2, and 3, 4, and we're going to try to reflect this over the y-axis, the x-axis, over the line y equals to -2, over the line x equals to 8. We're going to take the same triangle and perform these 4 different transformations to it. So the thing that you will need right now, you will definitely need a sheet of graph paper. And on the graph paper, you're going to need to draw an XY axis like I have. And then you're going to plot points A, B, and C on that XY axis that you've created. If you've done this, if you can pause the video and see if you can perform the necessary transformation, please do so, okay? So welcome back. We're going to perform a reflection. So when you're reflecting something, okay, the distance that the points are away from the line of reflection has to be the same on either side of the line of reflection. The line of reflection in this case happens to be the y-axis. So I notice that C is 3 away from the y-axis, A is 2 away from the y-axis, and B here is 6 away from the y-axis. So when we perform the reflection, on the other side of the line of reflection, it has to be the same distance away. All right, let's try it again. We're going to now take, and again, please pause the video and redraw another XY axis if you don't have enough room. So what we're going to try and do is we're going to reflect this over the x-axis now. So hopefully you got the chance to try and do this. We're going to perform a reflection, and if I notice here, these lengths, okay, or actually A is 1 unit away, C is 4 units away, and B is 2 units away. So on the other side of the line of reflection, those points have to be the same distance away from the axis of reflection. And those are the coordinates that we'll end up with. Next, we're going to try and reflect it over y equals to -2. So keep in mind, y equals to -2, is this a vertical line or a horizontal line? If you're thinking that this is a horizontal line, then you're absolutely right. We're going to be reflecting that triangle over the line y equals to -2. And again, it's the same process. We're drawing a line down to, perpendicularly down to the axis of reflection, and that distance is 3 units away. The next is 6 units away, and then the next is 4 units away. And those points on the other side of the axis of reflection will have the same units away from the axis of reflection. And then lastly here, we're going to try and reflect this over the axis x equals to 8. And how do we graph the line, the axis x equal to 8, you may ask? Well, x equal to 8 is a vertical line. So therefore, in order for us to accomplish this, we're going to draw a vertical line, okay? That is 8 units away. Or actually not 8 units away. That is x equal to 8, which is a vertical line that passes the x-axis at 8. So again, we're going to perform the necessary reflection. I'm counting here that they are 5 away from the axis of reflection, 2 away from the axis of reflection, and 6 away from the axis of reflection. So our final picture looks something like this. And these are our coordinates here. Okay, so let's take a look at the next situation here. Oh, actually, before we do, there is a note here. Note that the axis of reflection is always a perpendicular bisector of segments AA prime, BB prime, and CC prime. Notice that this axis of reflection here is a perpendicular bisector, right? Whoops. You see that? They're all the same length, okay? These are all perpendicular bisectors. All right. Next, we're going to reflect the triangle ABC, which is drawn, okay, over the axis y equals to x, and then we're going to do it again over the axis y equal to -x. So please pause the video and see if you can accomplish this on your own. But first and foremost, you have to know how to graph y equal to x. Y equal to x is a line, again, that passes through the origin, with a slope of 1. So it looks something like this. Pause the video, see if you can figure out how the image will look, how A prime, B prime, C prime will look. And welcome back. So the axis of reflection is that dashed line that I drew there. We are again going to count how far away each one of these points are away from the axis of reflection. And if you look at this, okay, again, we're going to do the same. We're going to count in the same manner, but instead of counting, horizontal and vertical distances, okay, we are going to count diagonal. So I notice here I have one diagonal, half a diagonal, right? So that means I'm going to go half a diagonal and then one diagonal. So A prime will be located here. Same thing over here. I'm going to go one diagonal, two diagonal, three diagonal, half a diagonal, 1, 2, 3. B prime will be located over here. And then similarly, one diagonal, two diagonal, and then 1, 2. This is going to be my C prime. So the image looks like that. And these are my coordinates. All right. And then the second half of this problem is we need to try and reflect this over the axis y equal to negative x. So a line that is y equal to negative x is a line with a slope of -1 passing through the origin. So it looks something like this. And again, we are going to be reflecting the points over that axis. So no fear, it's all the same thing. If you notice right now, A is half a diagonal away from the axis of rotation, so therefore axis of reflection. So therefore, A prime is going to be located over here because it's half a diagonal away. Same thing over here. I have one diagonal, half a diagonal, one diagonal. So B prime is going to be over here. Over here, I notice I have one diagonal. So therefore, on the other side, it must also be one diagonal. This is going to be C prime. So therefore, to connect all these points together, I'm going to use a different color so it stands out. So in blue, this is going to be my triangle. And there you go. This is going to be my final answer here, and these are all the coordinates. So there is a reflection an example of a rigid motion? Did the reflection cause any changes in the length of any of the sides of the triangle? Of course it didn't. So of course, yes, a reflection, okay, is an example of a rigid motion. The transformation preserves length and angle measures of the original figure. All right, so algebraically, okay, personally, I do not find this as useful, but then there certainly will be people who will find this useful, which is why I'm talking about this. There are formulas, okay, that you can certainly apply. However, I will encourage you to try to understand this by drawing the actual figure and performing the actual reflection. But algebraically, okay, there are formulas to which that you can adopt and apply. What are the formulas? If we reflect things, okay, over the y-axis, okay, A comma B. If you notice the coordinates for that particular example that we went over, the x-coordinates will change signs. The b-coordinates do not change, or the y-coordinates will not change. So therefore, I'll end up with A comma negative B. I'm sorry, negative A comma B. If we're reflecting over the x-axis, the y-coordinates will be negated, but the x-coordinates stay the same. So I end up with A comma negative B. If I'm reflecting over the line y equals to x, then what happens is the x and y coordinates actually ends up flipping. So it becomes B comma A. If I'm reflecting over the line y equals to negative x, not only do they flip, but they get flipped and negated. Okay, so this is the algebraic formula for performing a reflection. Personally, I do not find this as useful, but if you are one who prefers using formulas over actual over drawing things out, okay, then by all means use this, okay, and try to write this in an index card and study from this. Other horizontal or vertical axes, okay, other than y or x axes, you should pretty much just draw that out, okay? Creating a formula out of it will actually make the situation more chaotic. And that's pretty much it.